The next function we're going to take a look at is the tangent function, and I'd like to graph it and determine its period, its domain, and its range. Okay. Now, I just have to fall back on the definition, so I've drawn here my unit circle with the axes labeled as capital X and capital Y to distinguish between little x, which is the angle, the input to my function, and little y, which is the output, the trig ratio given by tangent, and the unit circle definition of that is just that it's the capital Y over the capital X value. Okay. So I'm going to pretend I don't know what this looks like, and so I would just say, well, let's look at what happens as we go around the unit circle once. So I'm going to start by marking off my quadrantal angles for that one revolution. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. So let's take a look at what happens there. Well, when my angle is 0, we're at this point right here. So capital Y over capital X would be 0 over 1. That's 0. So the graph of tangent is going to go through the origin. At pi over 2, the terminal ray of my angle passes through this point. Y over X is undefined because we would have 1 over 0, and we know we can't have 0 in the bottom. Now I'm suspicious that that means I'm going to have a vertical asymptote, but let's see if that makes sense. With secant and cosecant, when they were undefined, it was because we had a vertical asymptote. If I'm close to pi over 2, my capital Y value will be close to 1, and my capital X value will be close to 0. So I'm going to be getting something close to 1 divided by something small, and that same principle does kick in. When you divide by something small, you get something big. So at pi over 2, I will have a vertical asymptote. At pi, capital Y is 0, capital X is -1. 0 over -1 is just 0. So we've got another x-intercept there. At 3 pi over 2, once again, that capital X value is 0, so tangent is undefined. But again, we will have a vertical asymptote there because near any angle that passes through that point, my capital Y would be close to -1, and my capital X would be close to 0. So I'd be dividing by something very, very small. I'd be getting something very, very big. Okay. And then back at 2 pi, we get 0 over 1. We're back at 0. Okay. Now, I can see this is going to have asymptotes. It looks like with our quadrantal angles, we alternate. 0, asymptote, 0, asymptote, 0, etc., etc. I know when I've got graphs with asymptotes that I like to start and end with an asymptote, so I think I'm going to just extend at negative pi over 2, which is coterminal with 3 pi over 2, so it would put me passing through this same point. I'm going to have another vertical asymptote. And if I extended past 2 pi to 5 pi over 2, that would put me again on the positive y-axis, and again I'd have a vertical asymptote. Okay, let's just graph the part from 0 to 2 pi first, and then I'll expand so that I can start and end at an asymptote. What I'm going to do is I'm going to first show you just a very quick way to remember what the graph looks like. Okay, because so far with all the other ones we've just been plotting the quadrantal angles. Turns out that's not really going to give us a whole lot of information because it just gives us one point in between these asymptotes. Same thing happened with secant and cosecant, but somehow that wasn't so much of a problem. I'm going to show you a really quick way just to see the general shape of the graph, and then I'm going to go back and fine-tune it a little bit to get some additional points plotted. Okay. What I'm going to notice is that my quadrantal angles divide this x-axis here, which is the little x-axis corresponding to the angle, into intervals that correspond to quadrants over here. So angles between 0 and pi over 2, if I represent them rotationally, they're landing somewhere in quadrant 1. So this interval here corresponds to quadrant 1. I'm not sure that color is going to show up, so let me try a darker marker. Angles between pi over 2 and pi, if I represent them rotationally, they would land in quadrant 2. So this interval corresponds to angles in quadrant 2. Now, obviously, I'm not talking quadrant 2 on this graph. I'm talking quadrant 2 over here, where I'm representing my angle x rotationally. Here, I'm representing my angle x as a location on this horizontal axis. Angles between pi and 3 pi over 2, if I represented them rotationally, would put me in quadrant 3. And between 3 pi over 2 and 2 pi would be in quadrant 4. So it makes sense. Moving to the right along this axis corresponds to rotating through quadrants 1, 2, 3, 4, and then we repeat. We go 1, 2, again and again. And of course, between negative pi over 2 and 0, we're in quadrant 4. So moving along the x-axis, we're just going quadrant 1, 2, 3, 4, 1, 2, 3, 4, again and again and again. Okay, that's going to really help me because the quadrant determines the sign of things. So I know as we approach the asymptote, we've got to be getting big. But it's a question of, are we getting big in positive or big in negative? Well, angles in this interval would be in quadrant 1. In quadrant 1, tangent is positive, so we better be getting big and positive. So we'll be going up like so. Angles in this interval correspond to angles that would land in quadrant 2. In quadrant 2, tangent is negative because the y value would be positive, but the x would be negative. So we're going to be going towards negative infinity. Now, I'm drawing this backwards. Notice the function is actually increasing because remember, we read our graphs left to right. If I go left to right, we're increasing, but I find it easier to just start at the x-intercept and say, as I travel backwards, I'm going down. Okay. This interval corresponds to angles in quadrant 3. In quadrant 3, both x and y are negative, so this ratio is positive. So, we'll go up. And then this interval corresponded to quadrant 4. In quadrant 4, x is positive, but y is negative. So this ratio is negative. So again, traveling backwards, I'm going down. The function is still increasing as I read left to right, but I'm going to draw it going down. Okay, now I'm not happy with this graph. I'm not happy with it because I didn't start and end at an asymptote. So it looks kind of weird. I've got, this is a thing that tangent does. This is half a thing. That's half a thing. I want whole things. Okay, so if I want to start and end at an asymptote, I would say here this is quadrant 4 again. And here this is quadrant 1 again. So we've got that. Okay, I'm much happier with this because we started and we ended with an asymptote. If I look at this, it's kind of interesting. Okay, I'm seeing this do the same thing 3 times. It looks like it does its thing between negative pi over 2 and pi over 2, repeats it from pi over 2 to 3 pi over 2, and then repeats it again from 3 pi over 2 to 5 pi over 2. So it looks like the period is just pi. With all the other functions we've looked at so far, the period was 2 pi, which corresponded to a full rotation around the unit circle. Tangent, it turns out, repeats its pattern twice in one rotation around the unit circle. Kind of cool. So the period is actually just pi. So what I have graphed right here is exactly 3 periods. Again, make sure you read the directions. I'll usually specify graph at least this, or graph exactly this many periods, start and end with an asymptote. Okay. Now, the reason I'm not going to go back and fine tune this now, that I'm not super happy with this, basically happy with this helps me remember what tangent looks like. But it's a little hard to know exactly how steeply it should be going up. It's always going up, but how steeply is it going up? I don't have any other points to tell me. And so if I start doing some vertical transformations, it's going to be kind of hard to see. If I stretch it, what's stretched? So the period is pi. Okay. So this right here, from negative pi over 2 to positive pi over 2, that's one full period of the graph of tangent. If I just graph my quadrantal angles, I'm only graphing 1 point per period. That was okay for secant and cosecant, doesn't cut it so well for tangent and cotangent. So what I'm going to do is I'm going to say I want my increment still to be 1/4 of the period. So that would be, in this case, pi over 4. it's no longer going to correspond to quadrantal angles, but it's going to divide this up into 4 parts. And if I do that, that's going to have me plotting 3 points per period. So I'll have 1 point over here and 1 point up here to sort of tell me how steep the graph is getting. So if I started here at negative pi over 2, which happens to be, notice negative pi over 2 is the same as negative 2 pi over 4. If I count by pi over 4, I'd want to include a point at negative pi over 4 and at positive pi over 4. So let me just erase this curve that I just sort of sketched freehand. And I'm just going to sketch that one period with a greater level of accuracy, because I'm going to plot these additional points. Well, tangent of pi over 4, that's just my 45, 45, 90. That's just 1. Okay. So at pi over 4, we'd be at a value of 1. That just helps me to see how quickly we're going up as we approach that asymptote. And at negative pi over 4, I know tangent is negative because we're in quadrant 4, but my reference angle would be pi over 4, so it's actually negative 1. And that just helps me to see how quickly we're going down. So I will generally ask you to plot 3 points per period. That's what I'm going to consider the important points. So plot the 3 important points per period. This would be 1 full period with those 3 important points plotted. So just like with sine and cosine and secant and cosecant, I'm going to take 1 period and divide it up into 4 pieces. And that just helps me draw things with a slightly greater level of accuracy. Okay, excellent. So we've drawn our graph. We've stated that the period is pi. And then I'd also ask for the domain and the range. Well, the domain is going to be everything except the locations of the asymptotes. And we determined that the asymptotes occurred at angles that pass through one of these points. We've actually seen this before. Those are the same angles that are going to make secant undefined, because both tangent and secant have a capital X in the denominator. So if you remember, we said these were odd multiples of pi over 2. So the domain is going to be the set of all x such that x isn't an odd multiple of pi over 2, which I can write, I can squeeze that in here, as 2n plus 1, remember that's a way of giving me odd integers, times pi over 2. Don't forget to tell me that n represents an integer. Equivalently, I could also have said that's the set of all x such that x isn't pi over 2 plus a multiple of pi, again where n is representing an integer. Either of these is fine, whichever one you're more comfortable with. For the range, looks like everything. We're hitting all of our y values. So the range is everything from negative infinity to infinity. All right, good stuff. So in the next video, we're going to go over the graph of cotangent. Before you watch that video, see if you can, working with the unit circle, go through something similar, try and figure out what the graph of cotangent should look like. If you're already familiar with it, just try to confirm that that makes sense, given the analysis that we did in this video. And then state for me the period, the domain, and the range for cotangent as well.